Hello students, in this lesson we will discuss about the Fisher's method. Fisher's method of constructing index number. It is also called ideal method. Ideal method. The choice of method for construction an index number depends upon the objective with which a particular index number is constructed. So many formulas, so we can give the definition of this method, what this method says us, and what is the base of this method. Many formulas or many formulae have been developed and used by many economists for constructing index numbers, or constructing index number or index numbers, index number, but all may not be suitable for specific purpose in hand, but all are not suitable, but all are not suitable for specific purposes. For specific purpose, but all may not be suitable for the specific purpose. Some of the important formulae do not conform to certain appropriate tests of consistency. Some methods, some methods do not confirm some some tests of consistency, some tests of consistency. So we have different formulas for calculating or constructing index numbers, but so many methods are not in tune with the tests, do not comply the tests of consistency, But Fisher's method is such, but Fisher's method is one. Fisher's method is one which confirm the tests of consistency, and that is why we call it an index number. So Fisher's method is also considered ideal method for constructing index numbers. We have simple formula for Fisher's method is P01 is equal to under root of summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1 into 100. That is, we can write down it like this. It is under root of L into P. That is Laspierre's method into Paast's method, but we have to put under root. So this is the method which is ideal method, which confirm the tests, which passes the tests of consistency behavior. So what are the consistency tests? Now we will proceed on the tests of consistency. Fisher's method Why Fisher's method? Now the question is, why Fisher's method is called an ideal method? Why Fisher's method is an ideal method? Why it is an ideal method? Why Fisher's method is called ideal method? Ideal method. The simple answer is because it confirms the test of consistency. It is considered as ideal method because number one, it is based on variable weights. It is based on variable weights. Variable weights means it can take weight from current year as well as this base year. That is, its weight is based on both on current year and base year. It takes consideration both current year and base year for its weights. That is why we call it is based on variable weights. It is based on the weight of current year as well as the weight on the base year. It gives us some equal weight to base year as well as current year. If we take the Laspeyres method, that takes only base year quantities. If we take Post's method, that takes only current year weight into consideration. But this is a method, it takes both into both the years, base year as well as current year into. Second is, it takes into consideration the price and quantities of both the base year and the current year. जो हम डिस्कस कर रहे थे, it takes into consideration the price and quantities of both base year and current year. Both base year and current year. Third, it is based on geometric mean. It is based on geometric mean. So this method is based on geometric mean, which is regarded as best mean for calculating index number. Which is regarded as the best mean for constructing index number. So these are the three logics on which we call that it is an ideal method. One is it is based on variable weights. Now second, it takes into consideration the price and quantities of both base year and current year. First is it gives weights to both current year and base year. It takes into consideration prices and quantities of both base year and current year. And third is it is based on geometric method. Now the third concept which we have to clear that how Fisher's index number satisfies the consistency tests. We have two types of consistency tests. Now the third thing which we have to clear here, that is how Fisher's index number satisfy the how. We have here a small question out of the question between the lines. How Fisher's method satisfies the consistency tests. How it consistency tests. We have two types of tests. We can say that Fisher's index number satisfy both time reversal test and factor reversal test. That is why this is the fourth logic why Fisher's method is called ideal method. Why it is called ideal method? Because it satisfies the consistency tests. We have two types of tests in the index number. So a method which satisfies these two tests is called an ideal method. That is time reversal test and factor reversal test. What is this time reversal test? Now the question is, we can draw out questions out of questions. What is time reversal test? Time reversal test means if we reverse the time in the index number, that is, we change current year into base year and base year into current year, the ratio of index number of current year and the base year should be equal to 1. So time reversal test means if we change base year into current year and current year into base year, the product of two indices should be equal to unity. Thus an index number should work both the ways, forward as well as backward. Now we will discuss what is time reversal test. Time reversal test means if we change base year into current year and current year into base year, and into base year. Time reversal test means if we change current year into base year and base year into current year, the product of two indices product of two indexes should be equal to unity. So here the discussion is very clear. अगर हम बेस ईयर को करंट ईयर में चेंज करेंगे और करंट ईयर को बेस ईयर में चेंज करेंगे, जो हमारे दो इंडिसेस बनेंगे, दैट इज इंडेक्स नंबर फॉर करंट ईयर विथ रेफरेंस टू बेस ईयर एंड इंडेक्स नंबर फॉर बेस ईयर विथ रेफरेंस टू करंट ईयर, अगर हम उनको प्रोडक्ट दे देंगे, द रिजल्ट शुड बी 1. दैट मीन्स thus an index should work both ways, that is forward as well as backward. ये फॉरवर्ड भी काम करना चाहिए और बैकवर्ड भी काम करना चाहिए. It should work both forward as well as backward. तो कैसे हम ये देखेंगे? In numericals, with the help of numericals, किस तरह हम देखेंगे ये वाला? So time reversal test हम अगर उठाएंगे, first we will take the time reversal test. that is if P01 into P10 is equal to 1 is equal to 1। तो यहां हम अगर देखेंगे तो ये क्या चीज है, दिस इज P01 is index number of current year with reference to base year। ये P10 क्या है, ये P10 है इंडेक्स नंबर ऑफ बेस ईयर, इंडेक्स नंबर ऑफ बेस ईयर with reference to current year, with reference to current year। So P01 into P10 should be equal to 1, should be equal to 1। अब देखेंगे हम ये फैक्टर रिवर्सल टेस्ट क्या चीज है, व्हाट इज दिस फैक्टर रिवर्सल टेस्ट, दिस इज वेरी इंटरेस्टिंग। फैक्टर रिवर्सल टेस्ट, फैक्टर रिवर्सल टेस्ट, factor reversal test. It employs just as our formula should permit. If we interchange, if we interchange the two items without giving inconsistency test as formula should permit, the interchange of two items without giving inconsistency results. So it ought to permit interchange of prices. If we interchange the price, if we interchange the price into quantity, and quantity into price, and quantity into price, if we change price into quantity and quantity into price in a formula, if we interchange price into quantities and quantities into price without giving, it doesn't give inconsistency results, the two results multiplied together should equal to value ratio, that is without giving, it should not give inconsistency results, that is the two results multiplied, should be equal to value ratio, वो कैसे है, फैक्टर रिवर्सल टेस्ट ऐसे होना चाहिए, फैक्टर रिवर्सल टेस्ट सिंपल है, इट सीम्स वेरी डिफिकल्ट बट इट इज वेरी सिंपल। अगर हम प्राइस को चेंज करेंगे क्वांटिटी में, अगर हमारा ये है फिशर्स फार्मूला इस तरह है, P01 is equal to under root of summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q0। अगर हमारा ये फार्मूला है, अगर हम इसको ऐसे चेंज करेंगे, P01 बराबर है अंडर रूट ऑफ जहां जहां P है वहां Q लिखेंगे, समेशन Q1 P0 डिवाइड बाय समेशन Q0 P0 इंटू समेशन P के जगह यहाँ Q लिखना है, Q0 P1 Q1 P1 डिवाइड बाय समेशन Q0 P0। ये अगर हम थोड़ा करेंगे, इसको हम ऐसे करेंगे, यहाँ क्या है Q1 P0, यहाँ क्या है, ये है, तो इसके जो ये है the factor reversal test when P is changed into Q and Q is changed into P, their multiplication is this। अगर ये हम बनाएंगे अंडर रूट ऑफ समेशन P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q0। अब देखेंगे क्या क्या कट हो जाएगा। यहाँ क्या है Q1 P0 है, Q1 P0 Q1 P0 Q0 P0 Q0 P0, तो यहाँ ये आना चाहिए इनटू, हम अगर करेंगे इसको अंडर रूट ऑफ यही समेशन ऑफ P1, यहाँ Q1 है, दिस इज हाउ, दिस इज फिशर्स फार्मूला। तो यहाँ हम अगर इंटरचेंज करेंगे तो हमारा जो प्रोडक्ट है, it should not give the inconsistency results। So this is all about the factor reversal test and time reversal test. Thank you very much.